Alright, on C it says what is the sum of negative 15, positive 30, negative 60, positive 120, negative blah, all the way up to positive 480. Well, again, still going to be trying to see what the heck my R is. Well, from negative to positive, that means I have to be multiplying by at least a negative 1. From 15 to 30, I would be multiplying by negative 2. From here to here, I'd be multiplying by negative 2. And from here to here, I'd have to be multiplying by negative 2. So I do believe that my common ratio should be equal to negative 2. Alright. And then I also need what the heck a sub 1 is, which a sub 1 should just always be my first term in that sequence or series. Alright, and then finally I just need what the heck n is. So in order to find n, I'm probably going to have to use that explicit formula, which again is just a sub n is equal to a sub 1 times r to the nth minus 1. Alright, so a sub n is just going to be my last term, which in this particular bit is going to be 480, is equal to a sub 1 we said was negative 15, times r, which we said was negative 2, to the n minus 1. Alright, we'll use the calculator for a little bit and see what the heck this is going to turn out to. So divide both sides by negative 15. You should get negative 32 is equal to negative 2 to the n minus 1. And then we do maybe a little bit of guessing and checking to see maybe what n should be. So negative 2 to the what gives me negative 32. And we can type this into our calculator, trial and error. Or if you remember logarithms, you're perfectly allowed to use those. But again, we'll get to those next section. And when I say next section, I do mean next chapter, which means that this is the last section, so there will be a test coming around the bend. So I should get negative 2 to the 5th should equal negative 32. Since I want to be my exponent, that means I need to plug 6 in for n, because 6 minus 1 does give me that 5. Alright, so now I've got everything I need to use that little formula from way back here, which is that S sub n is equal to a sub 1 times the quantity of 1 minus r to the nth all over 1 minus r. So if you need to see it still, you should see it have S sub 6 in this particular case is equal to a sub 1 we said was negative 15 times 1 minus r, we said r was negative 2. To the nth, which is 6, all over 1 minus r, which is still negative 2. Alright, now we'll clean this up, which should all in all be about 315. And that does kind of make sense because remember it's going negative, positive, negative, positive, negative, positive. So really the net by the time we get to 480 is we've gained 315. That's about it. Alright, and then I believe we have 3 more questions. So it says evaluate the summation notation. So again, we need r, we need a sub 1, and we need n. Alright, so we should see that r is just going to be that negative 2 because, well, that's what's in parentheses, folks. Next thing that we need to find is a sub 1, and the first term, well, the first n that I'm going to plug in this time is going to be 1. So I've got 5 times negative 2 to the 1 minus 1, which is just going to equal 5 times negative 2 to the 0 power. Anything to the 0 power is 1, so really what I end up with is 5 times 1, which is just 5, so a sub 1, aka my first term, is going to be 5. Alright, and then the last thing that I need is my number of terms. Again, summation notation is pretty nice because I don't have to find necessarily the explicit formula because, well, 1, it's spitting you right in the face. And 2, I can just take the upper limit, which is 10, minus the lower limit, which is 1 in this case, and then add 1. Alright, so that should just be 10. Other than that, we just plug it into the lovely formula to figure out what the sum is. So we're figuring out the sum of the 10 terms is equal to a sub 1, which in this case is 5, times 1 minus r in this case is going to be negative 2 again, to the n, which we said was 10 in this case, all over 1 minus r, which we said was -2. Which plugging that into a calculator, I should get -1,705.